Welcome to Practice Unit 8 Continued. We're going to start by verifying a few identities, and I know these guys are your favorite, so it's where we're going to make our left side simplify it to make it look like the right, or prove that this expression equals 0 in this case. So pause the video right here if you want to try it by yourself first, give it a shot, and then come back. Okay, here we go. You saw that I already had these grouped with parentheses, so we are going to get a common denominator, and this common denominator is going to, I'm going to actually add things together kind of as we go. So the first fraction needs a cosine A plus cosine B multiplied top and bottom, so we're going to have in the numerator cosine A minus cosine B times cosine A plus cosine of B. And then we're going to be adding that to, and this fraction needed sine A sine B in the numerator and denominator to get something in common there. So we're going to have sine A minus sine B times sine A plus sine B. And probably you guys are already starting to see kind of what is coming out of this. Looks to be some binomials that could create some difference of squares, which is going to be super, super nice for our proof. So our common denominator that we actually ended up with is sine A plus sine B times cosine of A plus the cosine of B. Now I'm going to take a break from my denominator for just a minute and just work with the numerator and kind of show you, just in the interest of saving a little space here, kind of show you how you can continue to simplify this numerator. Difference of squares here is going to give us cosine of A squared minus cosine of B, or squared of B. We're going to be adding to that sine squared of A minus the sine squared of B. And in the next step, I'm going to rearrange some things and bring my cosine squared of A and my sine squared of A that are both positive together. And right next to that, I'm going to write my cosine squared of B, which is negative currently, and my negative sine squared of B. I'm going to write those together. And I'm going to start thinking about how I can use my identities, specifically your Pythagorean identities, to simplify this further. So this value here is going to be equal to 1. Right? Cosine squared plus sine squared of A is equal to 1. For this particular problem, what I'm going to do is I'm going to actually factor out a negative 1, leaving me with a positive cosine squared of B plus a sine squared of B, and that is also going to be 1. So that's going to be really nice here, because now I'm in the numerator, I'm going to have 1, and basically minus 1 times 1. So it looks like I'm going to get an answer of 0, which is handy because if my fraction turns out to be 0 divided by anything, in this case it was sine A plus sine B, super tiny here, times cosine A plus cosine B, right? Wouldn't matter what it was. This entire value is actually going to be equal to 0. So hope you guys saw that and worked through that okay. That's a pretty good one. All right, let's try another. Moving on, here is the next one, and I've just barely brought it onto your screen because I want you to have a chance to write it down first. Go ahead and write it down if you haven't, and then we're going to work through this one together. So I'm going to talk you through it a little bit. So here it comes. Here's the first step. You are going to have an expansion of cosine x plus y and cosine of x minus y using your identities. So cosine x, cosine y, sine x, sine y, okay, and then cosine of x minus y expands to be this particular value right here. We're going to move it on up and kind of talk through this particular problem, and then we'll continue on to the next one. All right, so again, this idea of distributing, having a middle term and an outside term that are going to be canceling each other. So it's kind of again, a difference of squares kind of a solution. And then what I did here is I made a substitution. I'm kind of use this green marker here. I made a substitution right here for cosine squared of x and right here for cosine squared of y. Now the part that gets a little tricky, because you're not seeing me write it out, is I went ahead and multiplied these two together. So it was the 1 times the 1 times the negative sine squared y. Sine squared x times 1 is right here, and then sine squared x times sine squared y was a positive sine squared x sine squared y. And that is actually going to cancel with this term that is hanging out there at the end. All right, and then we're going to go from there. So we still want to make it look like this, right? We want a cosine squared x and we want a sine squared y. Well, here's a sine squared y. Let's just kind of regroup these, and let's group the 1 minus sine squared x together and pop that negative sine squared y to the outside as we group these and make yet another substitution with Pythagorean identities. I get cosine squared of x minus sine squared of y, and now I have verified my identity. Woohoo! All right, next one. All right, write this one down. We'll give it a try. If the tangent of theta is equal to 6/5 and cosine of theta is less than 0, meaning it's negative, find cosine of 2 theta. All right, I'm going to go ahead and draw this because I like to kind of have a visual of where my tangent is positive, but my cosine is negative. I know that's going to be in the third quadrant. So I'm looking at a -5 and a -6. So -6 divided by -5 gives me my positive 6/5. And my cosine is negative. In fact, my sine will be negative as well in the third quadrant. So using Pythagorean theorem and a little simplification, we are going to get that opposite side. So 25 plus 36. So square root of 61 is going to be your hypotenuse. Okay, so when we're dealing with the cosine 2 theta expression, don't forget you have a lot of different choices for evaluating cosine of 2 theta. It is equal to cosine squared minus sine squared, right? It is also equal to 2 times the cosine squared of theta minus 1. It is also equal to 1 minus 2 times the sine squared of theta. So we can actually pick which one of these you would like to use. I know the cosine is negative. I'm going to go ahead and use this middle one, and I'm going to define my cosine of theta first as being my adjacent over my hypotenuse. So a negative 5 over root 61. Now I could rationalize my denominator, but because I'm going to be making this choice for evaluation, I'm going to be squaring everything anyway. I'm just going to use negative 5 over root 61. So it's going to look like this. 2 times the cosine, negative 5 over root 61 squared, and then minus 1. So that looks like we're going to have 2 times the quantity 25 over 61. I'm going to go ahead and change this one to a 61 over 61. And so my final result is going to be 50 minus 61, negative 11 over 61. Boom. Hopefully that went well for you guys. Okay, it's also nice to remember, and if you want some extra practice, you could also evaluate sine of 2 theta and tangent of 2 theta for the same value, just to get some extra practice with using double angle formulas. All right, last but not least, for our review, a little solving. So once again, pause, then come back, all right? And we'll try this one. Okay, something that you might notice right here is your cosine of 2 theta. And we just used, back in this other problem, an identity for a double angle formula that used cosine squared, all right? So I'm going to go ahead and make a substitution here for cosine of 2 theta, and I'm going to change it to 2 cosine squared of theta minus 1, and then I'm going to just write the rest of my equation out here. Cosine of theta equals 2, and it looks like because I have a squared term and a term for cosine theta that is not squared, I'm going to try and set this all equal to 0. So as I do that and I subtract 2 from both sides, I end up with 2 cosine squared of theta plus 5 cosine of theta minus 3 is equal to 0. So this problem is found on page 10 in your review. If you've already done it, great. I would try the other problems on page 10 as well. I think they're great practice problems to get you ready for your exam. And the keys for those are in Schoology, if you would like to kind of check your own work at that time. So one thing I like to remind people for a problem like this is another way to kind of tackle it is to look at, for example, 2u squared plus 5u minus 3. And if you have trouble factoring, sometimes seeing your expression kind of written in terms of a different variable can be helpful to the factoring process. Whoa, come back. Okay, so here we have 2u times u, and it looks like positive 6u and a minus 1 will create our 5u, which means if we can factor this trinomial in this way, we can come right back over here and factor this trinomial in exactly the same way. So zero product property states that we can set these components each equal to 0. What you'll notice about cosine of theta plus 3 equals 0 is that this is going to result in no solutions because we cannot have the cosine that is smaller than -1 or greater than 1. So there are going to be no solutions that are generated from this particular part of my equation. However, over here, we're going to end up with cosine of theta. Add the 1, divide by 2 is equal to 1/2, positive 1/2. And that happens on our unit circle when theta is equal to pi over 3 and 5 pi over 3. Okay, so there we go, a little solving for you to practice with your identities. All right, you guys are going to do great on this exam. I know you've been studying hard. I know this is an interesting way to tackle a unit exam for identities, our work with virtual learning right now. So stay positive, all right? So stay positive and just do your best, and it'll be great, and you'll learn a lot. All right, guys, we'll see you later. Bye.